Okay, let's take a look at 18b and 18c. 18b is the product rule. And the idea here is that your function is, let's call it h of h, is actually a product of two functions that you know. The question is, what is the derivative? The rule is keep the first times the derivative of the second plus the derivative of the first times keep the second. That's basically it. You can look up online how to derive that. It's simply, take h as it goes to 0 of the quotient, and then the idea is you're going to do a little algebraic manipulation to get the f of g's, f of x, and the g of x's together. It turns out that this is the answer. So let's just do some examples. So for example, let h of x equal 2x times sine of x. So once again, you have two functions. It's the product of two functions you know. So the derivative is equal to keep the first, the derivative of the second, plus the derivative of the first times keep the second. Final answer, 2x cos of x plus 2 sine of x. You don't need to do this. Yeah, good. Next problem. How about y equals e to the x times 2x plus 5 to the 6th power. It's a function. Look it up in Desmos. Like, see what it looks like. It's probably, just goes like way up really fast, but it's still a possible function. So the derivative is keep the first, the derivative of the second, plus the derivative of the first, keep the second. And you have to do a little work. So what is it? It's e to the x times 6 times 2x plus 5 to the 5th times 2 plus e to the x 2x plus 5 to the 6th. Final answer, we'll clean it up. What do we get? We get 12 e to the x times 2x plus 5 to the 5th plus e to the x times 2x plus 5 to the 6th. And we can do a couple more, just practice. So let me put another one up. How about you try, so I've used h of x, f of x, g of x, but you know that everything's called f of x. So once again, it's the derivatives, keep the first, derivative of the second, times, plus the derivative of the first, keep the second. So if I say, I don't know, how about f of x is equal to cosine of x times cosine of 5x, cosine of 5x, x to the 5th. Why don't you pause it and try it on your own? Okay, we're back. So f prime of x is equal to negative 5 sine x. Actually, let me keep to the rule I told you to do. So we're going to keep the first, derivative of the second. So it's 5x to the 4th cosine 5x minus 5 sine 5x times x to the 5th. You'll probably want to put the x to the 5th in front so it doesn't get mixed up here. It's just a visual thing. How about we try... Okay, so then how about I give you this one? So I give you y equals x squared over e to the x. Well, let's make it more fun. How about e to the 2nd x? And you're like, well, we don't know the product, we don't know the quotient rule yet. That's coming in a minute. But I can transform this into the product rule. So you can always write, x squared e to the negative 7x. And you're like, okay, I have the product rule. And then you write the answer. Keep the first, So it's negative 7x squared e to the negative 7x plus 2x e to the negative 7x. And you can clean this up a little bit, and you got negative 7x squared plus 2x all over e to the 7x. You could do that. I used to do it that way because I didn't like the quotient rule, but then I learned to love it. Another question you might get is, y equals, sine of x over, 2x plus 7. So you look at that and you're like, I don't know how to do it with the quotient rule, but you know what? I'm going to rewrite this as sine of x times 2x plus 7 to the negative 1. You have the product rule, so the answer is what? It's negative 2 sine x 2x plus 7 to the negative 2 plus cosine x 2x plus 7 to the negative 1. And then it just gets tedious. You just have to know how to manipulate. Make sure that you know how to manipulate this. Bring this down and then bring it together. The older books get a little crazy with this stuff. They're like, negative 2 sine of x over 2x plus 7 squared plus cosine of x over 2x plus 7, and then you have to bring these together. It just gets messy. That's like probably the late 90s, early 2000s. I just want to know how to do the derivative. This is probably better, but the question is, do I have to transform everything? Is there a quotient rule? And the answer is yes, there is a quotient rule. So let's take a look at the quotient rule. And I have a little song to remember it. So the question is, now we have h of x, and we have the product of two differentiable functions. I'll throw that in there. And so the idea is this on? Yes. The question is, what is the derivative here? And it turns out the rule is low d high minus high d low over low squared. So this is the low. This is the high because it's high up, and this is the low because it's low down. And so the derivative for the quotient rule is low d high minus high, let's call it high, like high d low, all over low squared. Some kids go back to the product rule. I say remember that. Low d high minus high d low over low squared. Low d high minus high d low over low squared. So let's take a look at these two. What was the first one? Let's go back here. So y equals x squared over e to the x. Okay, so the derivative is low d high minus high d low over low squared. Final answer, 2x e to the x minus x squared e to the x all over e to the 2x. Do we get that? Oh, I changed the sevens. Low d high minus high d low over low squared. Right? So what does this become? Sorry. Is that what we got? Yeah, we would end up... Yeah, because you factor out an e to the x. And will we get this? Yes. Nice. Sorry about that. What's the next example we had? What is the next example we had? What else do we want to do? The next example was so y equals, I'm going to erase this. So the next example, something easier we had was, how about 5x plus 2 over x squared plus 1. Just follow the rule. Low, d high, minus high, d low, all over low squared. Clean the numerator up and you're good to go. What do we have here? 5x squared plus 5 minus 5x cubed minus 2x squared over x squared plus 1 squared. Final answer, negative 5x cubed plus 3x squared plus 5 all over x squared plus 1 over 2. This is a little tedious, I get it, but this is a question that just want to see the derivative. Anything else? I would avoid using the quotient rule if you can. So, for example, let's say you have x. Let's say you have a g of x is equal to x squared minus 2x over x to the fourth. Am I using quotient rule for this one? What do you think? No, we're not. We're going to rewrite as x to the negative 2 minus 2x to the negative third, and it becomes a simple problem. Well, now that we have the quotient rule, I'm erasing these. Remember, low d high minus high d low. I'm erasing these, and now I can ask you what the derivative of tangent is. What is the, if y equals tan x, what is y prime? Well, what do you think? Well, I can rewrite tangent as sine of x over cosine x. And now I can do the quotient rule. Low d high minus high d low. I'm reintroducing this d. It means derivative. The derivative. That's how we know it. All over low squared. Remember this notation. This means cosine squared. What's going on here? Let's fix this up. Well, the derivative of sine x is cosine x. So we have cosine squared x, and then the derivative of cosine is negative sine, right? So we have plus sine squared x over cosine squared x. Once again, please remember, this is what? This is cosine, this is negative sine. And so that gives us, well, do you recall last year from your trigonometry? Sine squared plus cosine squared equals 1. And so we have 1 over cosine squared, which is secant squared. And that's why the derivative of tangent is secant squared, and the integral of secant squared is tangent squared plus c. What else can we do? We can now find the derivative of sine of x over x. This was important. We didn't discuss this, how to find the derivative of sine and cosine. We didn't go through that, but if you look at textbooks, this is complex method and you need to know the derivative of sine x over x. Well, we can use the quotient rule. So y prime is low d high minus high d low over low squared. I think that's it. So, and then some of these just become like tedious. Like, for example, they don't ask this anymore. This is like old, like AP stuff from like the 90s. Like they might say, y equals, open parentheses, 2x plus 1 over x squared minus 7 to the third power. And they say find dy over dx. And then you have to go through the whole, you have to do the chain rule, and then you have to do the quotient rule, and you have, like, it just gets very tedious. If you want to do it in comparing answers, or you can try this one, y equals the square root of x over, x plus 1. Same idea. These are just fun exercises if you're interested. Now you can do 18, I think it's B, and C. Or no, it's D, C or D. Yeah, B and C.